Okay, hello YouTube. This is my first ever live stream, so I hope it's going to work okay, and if it doesn't, can we all agree that we never mention this ever again? Okay? That's the deal. Hello RC Mad, thank you for joining me. This live stream is going to be about a Christmas present I've bought myself, but before I carry on, I'm going to turn off the Christmas lights in the solar shed because everybody can probably hear the ticking of that relay. So yeah, I bought myself an early Christmas present, and it's been sat for a couple of days in the shed. And hello Ron, hi there. And now I'm going to, I guess, do an unboxing. However, to be honest, I have opened this before just to check it was working because it arrived a few days ago. But I've bought myself, oh it's quite big, an oscilloscope. It's 100 megahertz, 1 giga sample per second, and 2 channel. And hopefully it's going to be really useful in the shed. Now it's quite big for my bench, as we can see, so without further ado I'll start getting it out of the box, which is difficult, I'll have to admit, but there we go. So it comes in a nice bag, and there's a power lead, a free gift of another probe type thing, and the proper 2 probes there and a manual. So I'll get it out of its bag and clear a bit of space, and perhaps I should move the camera out a little bit further. Oh, this is nice, I've got various people joining me. Excellent. So we'll need some power in a minute. But yeah, this comes in a bag. I bought a deal, I guess, which included the bag. And as you can see, even though I have briefly had this out to check that it works, I've packed it up good and proper. So and get the various bits off it. And there we go. So it's an 01, let me move that down a little bit, 01 SDS 7102V. So it's 100 megahertz, 1 giga sample per second, 2 channel. It's got this lovely big 8-inch screen on it, bigger than most. I know the Rigol, which is pretty popular, and the Hantex, well the Rigol's got about a 6-inch screen, I think it's quite small and a low resolution, but the Hantex has got a slightly bigger screen, but this has an even bigger one, 8 inches, which doesn't sound very big compared to your laptop, but is considerably larger for most oscilloscopes. So if I can get some power in, ready to go, and everything's just falling off the wall in the shed. Right, so it's pretty good. It's really thin compared to a lot of oscilloscopes, and that's one of the primary reasons I bought it. As you can see, my bench is so small, having such a thin oscilloscope is really useful because, sorry if I move the camera again, we can see it leaves me quite a bit of space. It's about 70 millimeters deep. What's that, about 3 inches? And most oscilloscopes are twice as thick as that, or as deep as that. And to go with that, the power is on the side, and on the other side we've got the VGA, the USB in and out, and a RJ45. And the only thing on the back is the pass-fail BNC. So this one, for that reason, was probably the best one for the shed. Aha, hello Julian, thanks for joining me. It's partly your fault why I've ended up buying this. But anyway, the other reason why I bought this one in particular, although I know Dave Jones wasn't particularly pleased with it, and it can be a bit slow, I think, is that there at the bottom, in this hole, if you take these two screws out, it's a lithium-ion battery. So this can be used without mains, but for now at least, I'm going to plug it in. I've got some 240 volt here in the shed, which we don't like to have here very often, but let's turn it on. So there is a fan in it and it is whirring slightly, but it's not too bad, to be honest. Perhaps you could comment if you can even hear it. But it takes a few moments to boot up, and there we have it. So both channels are on, and I've got a few experiments to do with it, and knowing my luck, most of them will fail, but hey ho, in for a penny, in for a pound, let's give it a go. So if you're just joining us, I did say right at the beginning of this live stream that if I make a complete and utter fool of myself this evening, can we all agree to pretend it never happened? That would be really useful if everybody would agree to that. Thank you. So I need to find my probes, which have fallen on the floor. There they are. 2 probes in the same bag, and of course you get the little compensation tool in there as well, and some spare coloured collars. And they seem of decent quality. They're certainly better than any of the JYE Tech stuff I've used before, so it's definitely a step up. But if we plug those in, let's connect one up to the test, and there we go. Trigger down a bit even, that's the one. There we go. So we've got a, let's put the other one on as well. Excellent. So there we go, we're seeing a couple of traces there. How's that showing up on camera? Not too bad. Not too bad. If I adjust the lighting, perhaps that's a little bit better. Yeah, so I'm really impressed with the screen, definitely. I know that, like I said, Dave Jones has done a review on this series of oscilloscopes, and he wasn't too impressed by the quality of the buttons and stuff like that, but I don't know, I think it's alright. I mean, I've not much to compare it with, in all honesty, so well, I say not much to compare it with. I have my JYE Tech DSO 112, which has been fine and really useful, and you know, I've learnt a lot about oscilloscopes and electronics from this little oscilloscope, but it has its issues, so it's time to upgrade, definitely. So what should I do? I've got my little function generator here. I can't remember, it's based on an XR chip and I can't remember what it's called. Would have been better to remind myself of that before I did this impromptu live feed. But if we get some power into there, we can also put these. So if I put channel 1, or is it that one? Where's my ground? Is that ground? No, this one is ground. Of course, I've put it on channel 2, haven't I? So if I go into the channel menu, DC coupling, where do I do? Trigger menu, source, trigger 2. There we go. And there we go. So that's a sine wave there. We can speed that up, and there we go. I mean, it's a great little tool, this, and it was a nice little project to build. Actually, I think they're only about £7, less than $10. It does sine waves, it does triangle waves, although I've noticed it cuts off the top and the bottom of that sine wave if the attenuation is too high. But that's not too bad, is it? Quite pleased. I think I can also use the other output here. There we go, I've got square wave as well. Lovely. Move that one down, move that one up. Excellent. So we can look at measuring those in the measuring menu. So if I add a measuring, we can see add frequency. So they're currently running at just over 800 Hertz there, and that's pretty cool. We can turn it up, and this function generator allows me to wrong one, try again, get used to what you're doing. There we go. So now we're running at almost full whack of this function generator, and the square wave's got a little bit dodgy there, but never mind. So I'm quite pleased. It's got maths. We can do dual waveform maths, add, minus, times, divide, channel 1, channel 2, that's all super, isn't it? There we go. A green maths trace there on the screen. Excellent. I'm really pleased. This is fun. I did have a question after one of my videos a few weeks ago, when I was testing my inverter, and you may remember I had this big resistor, and I was looking at, I was trying to work out the DC current that was being pulled through my inverter with my clamp meter, and I made a mistake and I left my clamp meter in AC mode rather than DC mode, and it read the wrong figure, so it read the wrong result, didn't it? And I then did a follow-up video using my JYE Tech oscilloscope, and said we could see the waveform on the oscilloscope there of actual current going up and down. So I thought it might be worth plugging that in and seeing if we can try that as well. So if I turn that one off, I'll turn the second channel off as well, and I'll disconnect all of this stuff, and yeah, we might use that again in a minute, that little function generator. And there's my big, let me just see if I can widen that up a bit. Can we still see everything? Sorry about the shaky cam there. Channel 1, oh look, I've got my probes the wrong way around. No wonder things were confusing. Let's put the red connector on channel 1 where it's marked red on the oscilloscope. Okay, so we're going for my red probe on here. That's the lower side of the circuit, and that's the higher side. I'll just check these are on. Yeah, times 1. So there we go. Right, so in that experiment I had a 45 watt incandescent bulb plugged into my little modified sine wave inverter, and we saw 10 volts per division. That's probably a bit much, isn't it? And we saw that interference. So let's turn it on again. There might be a bit of noise in the background, I'm afraid. Oh, it's not actually on at the moment. Everything's collapsing. These are the sorts of things that usually get edited out of my videos. And there we go. No, that's not even working. What's up with that? Oh, my negatives come out of the wall. This is terrible. Perhaps we might have to miss this experiment, or I need to find a screwdriver and fix that very quickly, and I'm sorry because there's not a lot on the screen that's terribly interesting to look at while I'm messing around sorting out my dodgy wiring. So don't anybody suggest I sing a song to entertain. Right, that needs to go in there. And we'll tighten that up. Lose my screwdriver on the floor. Excellent. Right, sorry about that brief interlude. Right, so turn it on at the breaker. Excellent. Right, so I've got something happening now, and that is going to need to be much lower. Oh, I'm seeing all sorts of noise. There we go. I think that's pretty much what we saw on the JYE Tech oscilloscope before, when I had issues with my interference. So what are we seeing here? The vertical is set to 100 millivolts per division, so we're seeing a ripple there of sort of 350 millivolts. In fact, if I go to measure, add channel 1 type, and I think, what, peak to peak, yeah, oh look at that, so escape, this is now saying 368 millivolts there of ripple coming from, on the DC side, going across this resistor from my inverter. And its frequency is interesting. It's 98 Hertz, just a little over 98 Hertz. Now obviously the output on that inverter is 240 volts and 50 Hertz. So I guess it's twice the frequency it's creating. So that makes sense actually, doesn't it? So it's inverting positive, then negative, 100 Hertz. Well, actually then, I'm not too worried about that. So that's pretty good. Sorry, I'm doing a terrible job of looking at your comments, because it's very difficult to do that on my camera. I have got another laptop here, but as you can tell, it's all a bit unorganised, this, isn't it? Well, it's a live stream, I guess things go bad or wrong when we're live. Julian asks, Adam, how do you heat your shed? I don't. I'm wearing a hoodie. It's a particularly mild night tonight, actually. If I was doing this on Monday, I would have been absolutely frozen. But I don't have any formal heating here in the shed, other than all the electronics. Right. That's really interesting. I'm going to turn that inverter off, and that's been an interesting little experiment for me, if for nobody else. And I'm really pleased that ripple there is explainable. It's not something daft or particularly worrying about my little inverter. Not that I ever use it all that much, to be honest. The audio is good. Oh, that's good. Thank you very much, Zan. Nice to have you along, Zan. So, like I said, this was an impromptu idea, and what we've been going 20 minutes now, and I don't want to bore everybody too much. It's nice to have you all along. But the last thing I want to have a little play with on my new fancy oscilloscope is something I've put together here. It's just an Arduino Uno, and it's got one of those shields on top with a little breadboard. And what on earth's going on there? Oh, that's not so good, is it? My oscilloscope just rebooted itself. That's a bit disappointing when you spent a few £100 on something and it sits there and it reboots. And again. Oh no. Let's turn off the main power. Now, if you didn't join me right at the beginning, one of the reasons why I went for this oscilloscope was it's very thin there, so it can fit on my bench and sit right at the back. And the other reason was it's got a battery inside. So actually I won't need to run it off the mains very often. I think the battery's meant to last for about 4 hours. So I'm actually powering it now off the battery, aren't I? So I can remove that mains, turns that LED off, and hopefully we won't have it rebooting again. I haven't done anything about the firmware or anything like that. I know you can download the firmware from the Lilliput site who make this, who use the name 01. And so on with the stream, I guess. So this is a Arduino Uno with a little breadboard and a breakout board there, and if I can find some 12 volts to put into it, and if that goes in there, lights are on underneath, we can see that powered up. And let's see, so we need some ground, which will do there. We need that one, and we need that one. And hopefully, if I put one there, turn on channel 2 as well. And, oh no. Oh, how disappointing. Oh no. What on earth is causing that to happen? Right, let's turn it off completely. Oh, I seem to have bought a pup. Everything's connected quite happily. Let's disconnect everything, make sure it's happy. In fact, pull that out now. Julian, the battery indicator is not saying anything actually. Let's try plug the power back in again, see if it's low voltage or something. Right, so we've got a red light which I think will mean charging, and it is acting a bit more reliably now. So yes, AC's back in. There we go. We've got both traces back on again. Let's start again. This could only happen, you know, in a live situation, couldn't it? Not in one of my regular videos where I could have at least edited out some of that rather than deny it ever happened. But let's plug all this back in again. Right, where are we? Have we got anything? So there's a trace there, and there is, right, good. So we've got 2 traces. Trace 1 and trace 2, they don't look terribly interesting at the moment, do they? But let's zoom in there, and we'll go to Maths, FFT, no I don't mean that, dual waveform, sorry, turn the maths off. What I meant to do was, of course, display XY mode. Oh, it's the wrong way round. course it is. There we go, look. Can we see that on screen? Green doesn't come up well actually, does it? Let me just reduce the light intensity. No, that's not coming up very well, is it? But if we put persistence on and 2 seconds, come out the menus. Look, in XY mode I've made a Christmas tree. Well, this was my Christmas present to myself. Hopefully it won't need to go back, and it is just a low battery. Can it pick up the voltage potential between your hands created by your heartbeat? Oh, I don't know about that. That's probably a bit... it's probably a little bit much for tonight. But yeah, okay, so we can just make that out, can't we? Little Christmas tree in XY mode. And if I decide to put this video up, I'll make sure we've got a link to the sketch. Some kind gentleman created this little Christmas tree in Arduino sketch, and I found it on the web, and there we go. So we can make a nice Christmas tree. And yeah, so despite the fact that it's completely rebooted a few times, and that might be my fault rather than its own fault, yeah, I think I'm pretty pleased with my new 01 SDS 7102 oscilloscope, and I guess a Merry Christmas to you all, and this is my present to me. So yeah, Merry Christmas to you all, and I'll see you in the next video. If you like this, give it a thumbs up. Thank you for all your comments and all the loads of viewers. Actually, I'm really surprised I've got 45 viewers. That's absolutely amazing. Thank you very much for your time tonight. Good night.